This clip we will learn about effective and RMS value for the RMS, which is come from root, mean, square value. For any periodic x of t signal, the RMS value is defined by x of RMS is equal to square root 1 over t integrate from 0 to t x square d t. So this one is root, right, and mean, and then square. And so for the circuit, we have a voltage or current written in and our voltage and current is a sinusoid, so IT can be represented by I max Im cosine omega t, and the RMS value of the current IRMS is equal to 1 over t integrate from 0 to t Im square cosine omega t square dt. And since this term is constant, so we move out, so we will have square root m square over t integrate 0 to t, and since cosine omega t square is equal to 1 over 2 1 plus cosine 2 omega t, so we integrate 0 from 0 to t 1 over 2 1 plus cosine 2 omega t dt. This one is constant, so we move out, so and we integrate inside, so the inside will be integrate 0 from 0 to t dt plus integrate over period of cosine 2 omega t dt. And this first term you come up with the t from 0 to t, and this term we integrate cosine 2 omega t dt, we obtain sine 2 omega t, and the length of the integral is from 0 to t. So when we put this in, the limit in, then we will have square root of Im square 2t multiplied by t, and this one is sin sine 2 omega t equal to 0 and sine 0 equal to 0, so this become this t deduct it out, so we will have square root Im square divided by 2, which is equal to Im divided by square root 2. And it turned out that IRMS is equal to Imax divided by square root 2, or which is equal to 0.707 Im. And similarly for the voltage also have the same form, Vm cosine omega t. So when we derive it, we will come up with VRMS is equal to Vm divided by square root 2, which is equal to 0.707 Vm. And we know that for the AC signal, the average power P is equal to 1 over 2 Vm cosine theta V minus theta I. So we convert 1 over 2 into 1 square root 2 multiplied by square root 2, so we come up with Vm divided by square root 2 and Im divided by square root 2 cosine theta V minus theta I. So the average power of the AC circuit when we written in terms of VRMS is equal to VRMS IRMS cosine theta V minus theta I. For this formula is very easy in practice, because generally our meter it measure the measured value come in form of the RMS value. So we will know VRMS and IRMS by just measure it. And so next, how about effective value? The effective value of periodic signal, which is for here is let's start with the current, is the DC current that deliver the same average power to a resistor as the periodic current. So we will have a source, periodic source VT, and we have a IT passing through this resistor. So it's and we would like to have a DC source. We call it V effective. And so for this DC source, you will have a AC current I effective, and I effective passing through this resistor, and we would like to have the same average power to a resistor. So let's find average power of the resistor in AC circuit. So the average power P is equal to integrate over I square R dt divided by 1 over T, and integrate within one period. So R is constant, so we take it out. It will be equal to R over T integrate I square dt, and since I is equal to V over R, so this I square become V square over R square. We move R square out and R deduct with R square, so we come up with 1 over RT integrate V square dt. And this one is the average power absorbed by this resistor. And then take a look at DC circuit. For DC circuit, we know that power P equal to I square R or V square over R. So for this one, I is I effective square multiplied by R, and P all equal to V effective square divided by R. And since we aim at this PAC must be equal to P DC. So it means that for example, in terms of I, integrate 0 to T I square dt R over T must be equal to I effective square R, and we have the same term. So it means that I effective equal to square root 1 over T integrate from 0 to T I square dt. And you know that this one is the root mean square, so we come up that, so we can summarize that I effective is equal to I RMS, and similarly V effective is also equal to V RMS. So in summary, the effective value of any periodic signal is its root mean square value, and the average power can be written in terms of both of the V maximum VMIM, which is equal to 1 over 2 VMIM cosine theta V minus theta I, and it can also be written in terms of RMS value VRMS IRMS cosine V theta V minus theta I. And for special case, for resistor theta V equal to theta I, so cosine 0 is equal to 1, so P will be equal to VRMS multiplied by IRMS, or 1 over 2 VMIM, or and since we know that V can be replaced with IRMS divided multiplied by r, so p is also equal to RMS square multiplied by r and equal to v RMS square divided by r. So any VMS is equal to Vm divided by square root 2 and IMS equal to Im divided by square root 2, and our household value is the RMS value 220 volts. And as I told you that why we have to derive the relationship between average power and RMS value is that because all of our meter, the readout of the meter are RMS value, not the maximum value. If you like to get the maximum value, we need to use oscilloscope, and it's kind of inconvenient compared to using the voltmeter and ammeter. Let's try to practice on how to find the RMS value of variable time variable signal. Given the signal on the screen, you can see that they ask you to determine the RMS value of the IT. If the current is plus 2 ohm resistor, find the average power absorbed by the resistor. To find the average power, then we need to find VMS or IMS. So this one they give you the current waveform, so we will find the IMS, and we know that for any periodic signal, this one is a periodic signal, and the period t is equal to 4 seconds, and so for any periodic signal, IMS is equal to square root 1 over t integrate from 0 to t I t square dt, right? So we have to come up with the IT function, and you can see that for IT function, this one is the straight line, and the slope is equal to 10 divided by 2, so it equal to 5. So from function of IT equal to 5t when t start from 0 and less than 2, and then this one after 2 until 4 it is constant, and the magnitude is equal to -10, so IT is equal to -10 from t equal to 2 from t between 2 and 4 sec. And so now we can use this formula to find the IRMS. So IRMS is equal to square root 1 over 4 integrate of 0 to 4. Our time period is 4, right? So it's a piecewise function, so we integrate first term 5t square dt, and then plus here, let I move it here. Plus integrate of -10 from 2 to 4. This one must be from 0 to 2, and then the square dt. So this one is equal to 1 over 2, right? Okay, it's equal to 1 over 4, 25, right? So it will be 25 from 0 to 2, minus 10, so plus 100 t from 2 to 4. So this one which is equal to 8.165 amp, and this one is RMS. And to find the average power, P is equal to RMS square multiplied by R is equal to 2. So it is equal to 8.165 square multiplied by 2, which is equal to 133.3 watt. Let's work on another example. Find the RMS value and the amount of average power of the given sine wave rectifier, and then this the average power dissipated in 10 ohm resistor. So we know that VRMS is equal to square root 1 over T integrate from 0 to T Vt square dt, and T is equal to 2 pi. And for Vt we have two pieces. So Vt first piece is from T from 0 to pi. We will have a sine wave of magnitude 10. So Vm is equal to 10 sine T. And then the second half is 0 from pi to 2 pi. So VRMS is equal to VRMS square is equal to 1 over T integrate from 0 to T Vt square dt. So it will be equal to 1 over 2 pi integrate from 0 to first piece is 0 to pi 10 sine T square dt plus integrate 0 dt from pi to 2 pi, and this one becomes 0. So we have this one, and so it equal to 1 over 2 pi integrates from 0 to pi 100 sine square dt, and this 100 sine square the sine square is equal to 1 minus cosine 2t dt. So we integrate this, we obtain 50 over 2 pi integrate dt multiplied by t minus sine 2t divided by 2, and the limit of it from 0 to pi. And so we will have this equal to 25. So this one is a VRMS square. So the VRMS is equal to square root 25, which is equal to 5, and P is equal to VRMS square divided by R. And so RMS square is 25 divided by 10. So we have 2.5 watt. And the last slide, we just last slide, I just want to show you the important term of all the sine wave. And so for any sine wave, we will have peak value V peak, and we often use it as a Vm or Vmax or Vp. And then we will have V peak to peak, which is equal to twice of V peak. And so we have VRMS value. VRMS is equal to 0.707 V peak or Vm, which is equal to Vm divided by square root 2. And often you will see another term, average value. Average value, they will go to find the average value of this cycle. This one like only find the positive value, the absolute value, and it will be equal to 0.637 V peak. And so this is important term, and if we have some kind of offset, then this sine wave can just move up or move down, depending on you have a plus offset or you have a minus offset value. So to find the RMS value, we use the same formula, which is if you have x of t, then the RMS value is 1 over square root 1 over t, integrate from 0 to t, and then x square t dt. So the form that we often involve with is a square wave, sine wave, triangular wave, and sawtooth. And you can see that different waveform will come up with a different RMS value. We end it with this RMS value of the 4 waveform.